So at the end of part 1 of this lecture, I posed this question. How did you do? Well, note what we want to do, because we're subtracting a multiple of b from some multiple of a, is draw negative b. That will be useful. And whatever drawing is correct here must have negative b in it somewhere. Now notice there's only one of them that actually has a vector pointing in this direction. It's e. And so if you look, here's 1a, 2a, 3a, and then minus 1b, minus 2b, and we started here and we end here, so we draw the result this way. And so e is correct. You might have been tempted by d, but note, d isn't 3a minus 2b, it's 3a plus 2b. b points in that direction, and there are two of those here. C technically is showing a minus b, even though that's b there. But note, you go a, and then you go backwards through b. I don't encourage you to ever draw vector subtraction this way. It just tends to confuse people, because once you've drawn it, it's unclear whether the result should point this way towards this end, or this way towards this end. A and b have nothing to do with 3a minus 2b, because these vectors are neither b nor negative b. They're an incorrect attempt to flip b end for end. Now that we understand, at least graphically, how to carry out vector addition and subtraction, we can use that to look at one of the most important concepts with vectors, which is decomposition of a vector. Decomposition just means breaking it into pieces, and there's a particular way we're going to break it into pieces. First, we're going to define some axes, and we can define the axes any way we want. I've drawn the way you're probably most comfortable with. And we shift the vector right onto the axes, or you can think of it as shifting the axes to the vector. In any case, now we drop perpendiculars from the tip of the vector onto each axis, and it's very important that these are perpendicular to the axes. Replace those with two vectors that we're giving very particular names. If the vector is a, these are the vectors ax and ay. And now, just rearranging them, you can see that a is the vector sum of ax and ay. Ax and ay are what we call the component vectors of a. They're two vectors that point parallel to our chosen axes, which add up to give the vector. The sizes, or magnitudes, of the component vectors are what we call the components of a. So the notation is that ax vector and ay vector are the component vectors, which add up to give a, and ax and ay, which are scalars, are the components. Notice the component vectors must be perpendicular to each other because they point along the axes, and the axes were perpendicular to each other. And so whenever we do a vector decomposition, the original vector is always the hypotenuse of the triangle formed with its component vectors. You may have already learned how to write down a vector in terms of its components, and that's good, and we'll look at that in a moment. But remember, the vector is not its components. The vector is the arrow. The reason that's important to realize is that if you keep the vector the same but redefine your axes, you'll end up with different components, even though the vector itself hasn't changed. And in fact, we don't even have to define our axes perpendicular to each other. However, you get into a lot of mathematical complications if you use axes that aren't perpendicular to each other, and so we won't do it, and that's the last I'll say about that. Here are a couple of vectors, and here are some axes, and I haven't even put units on because perhaps these are abstract vectors. How do you read these vectors off of the pictures? Let's start with this a. This a is defined by two components, and I'm going to draw what they are here and here. We would call this distance along here the x component of a. And we would call this vertical distance here the y component of A. Now notice, I've put a vector symbol on A because it is a vector. I haven't put vector symbols on the components. They aren't vectors, they're scalars. Well, what are AX and AY? You can probably see AX is just 1, 2, 3, 4, 5. And AY, well, A points downwards, and Y is increasing in the positive direction upwards, so AY must be negative. And so AX is 5, and AY is negative 3. And we can now write A this way. I would write it as 5, and this funny I symbol with a hat on it, minus 3, and this funny J with a hat on it. Okay, those might look intimidating, but there's no need for them to be intimidating. This I hat just means in the positive X direction, and this J hat just means in the positive Y direction. So you just read this 5 in the positive I direction and minus 3 in the positive Y direction. You may have learned to write a vector like this as an ordered pair, like so. Or perhaps using angle brackets instead of round brackets. That's fine. Also, because here the labels tell you which component is which, there's nothing wrong with reversing their order. You could write it this way, but if you use this notation, it's the order that tells you the first one is the X component and the second one is the Y component. Note, many students would look at this vector and incorrectly say that its X component is 6 and its Y component is 2. Do you see why they would say that? That's where the end is, isn't it? But that's not what we care about. What we care about is how far over and down this vector carries us. So similarly, this B, I hope you can see, is negative 2I hat plus 3J hat.
Let's check your understanding of this. Here is a vector on a grid, and I want you to choose which of these is a correct way of writing down this vector. As usual, if you're doing this through Moodle, Moodle will ask you this question before taking you to the next video. If you're not doing it in Moodle, then you should still try and answer it before you move on to the next part.